화장한 나 얼굴을 찌푸려 쉴 틈 없게 한숨도 내쉬네. Wait 잠깐만 고개 돌려봐봐. 창밖에 쏟아지는 sunlight. 웃을 이유는 충분해. 빈수면까지 내리친 태양 아래 웃어봐. 더 예쁘게 더 자연스럽게 장난스레 찡그린 건 okay. Yeah 완벽하지 않아도 계속되는 take. 하나씩 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 1, 2, 3, 4 say cheese. 매 순간이 특별한 듯이 pose it pose it 가볍게 take it take it yeah. Cheers 끝까지 미소 짓는 느낌. 한 번 더 한 번 더 괜히 입꼬리를 올려. Cheers 말없이 골똘하게 뭔가에 깊이 빠진 듯한 표정. 때론 이런 게 더 좋은 것 같아 살짝 담았네. 사진을 꺼내볼 때마다 선명히 그려주리 찰나. 꽤 괜찮은 것 같아 yeah. 단 한 번뿐인 소중한 순간 속에 웃어봐. 더 예쁘게 더 자연스럽게 장난스레 찡그린 건 okay. Yeah 완벽하지 않아도 계속되는 take. 하나씩 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 1, 2, 3, 4 say cheers. 매 순간이 특별한 듯이 pose it pose it 가볍게 take it take it yeah. Cheers 끝까지 미소 짓는 느낌. 한 번 더 한 번 더 괜히 입꼬리를 올려. Cheers 불쑥 바람이 불어 머리를 흐트린 채로 새로 채우는 한컷 이 모습 그대로 좋아. 그동안 필름의 시간을 채워 yeah. 꼭 웃지 않아도 돼 자유롭게 모든 모습을 다 소중하게 yeah. 완벽하지 않아서 더 재밌는 take. 하나씩 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 1, 2, 3, 4 say cheers. 매 순간이 특별한 듯이 posing posing 가볍게 taking taking yeah. Cheers 끝까지 미소 짓는 느낌. 한 번 더 한 번 더 이 순간 너와 나의 모습 그대로 하나 둘 셋 cheers.
Good evening. It looks like my channels are probably correctly assigned. Give me a yell if you can't hear the Bingley background music. Yes, I apologise for the small dot in the A of my startup test card. I don't know what that's doing there, and I will go in search of it later. Actually, if I click that and then say properties, that should tell me what that's capturing. Yes, it's capturing the right thing now. More tea. Yes, please. More tea would be lovely. Thank you. Good. Jacob can hear both Ben and Plinkle. Right. So.
Hello, Jacob. More squash when you're ready.
Last session we successfully constructed.
Squawk. More squash, please.
The Three Kingdoms sandwich. No, hang on. Get the two separate. The Three Kingdoms coin acceptor, which counted out people's change and didn't appear to cause any serious trouble. And Carl was slightly sarcastic about it. And the sandwich assembler, which Joe invented, and which yes, appears to have raise the ire of his superiors or some such. So our chief engineer seems perfectly happy, but then he doesn't have to sell the things. Patriotic sandwich machine, yes, which like appears to work.
Believe that. State it again.
So Lily Wu has come up with a job of creating a highly portable infrared targeting device. Joe has come up with an even worse scheme of constructing a haunted doll. I can't see any way in which his scheme actually makes the company any money. Like, as far as I can see, he is planning to construct these dolls, distributed them along with normal dolls, so presumably that means they're not dolls that we're selling, and cause them to thus terrify people. Yes, but we don't get the internet points. That's the problem, because no one will know that it was Shenzhen Longteng Electronics Corporation. Yes, but I expect our sales guys to have a slightly closer connection to profit than the rest of us. I don't need a 2 ... scheme step in their schemes. And we have the ability to write custom tech specifications, where when I click the button it opens up gedit with a pile of Lua in it, which is probably not the right thing for the stream, plus a bit for pain to well, yes, it does say to go viral, but the problem is, even then, like, I suppose then we have people track down who it is that made these things, and then they'll find out it was Longteng, and then something good will come of it, maybe. And we also have some older things available. We have Lily's earlier ones, essentially. Well, Lily and the Xinjiang thorium miners. Which, like, should at least be reasonably easy. So we need to pick a direction. Does anyone have any opinions about what I should build? Or there's, of course, prototyping new ideas, but I think that may require some actual preparation on my part.
I've not been here, I've got no idea what's going on. I think you should build the third thing.
I've got two votes for Haunted Doll.
Was that the third thing?
1, 2... No, I think the Carbine No, I think... hang on. 1, 2... Yes, I think the Carbine Illuminator was third thing, so... Simon has voted for Springer. So I think that means we're building the Haunted Doll. Right. So we have in the data sheets or rather in the creepy sound effects, in the bonus supplemental data, a printout of Dark Lord 555's creepy sound effects page, designed for Internet Explorer 3.0 or better, so that's been around for a while. Seb suggests we can make a haunted doll with swords for helicopter blades, which is a completely unintelligible comment out of context. Right, so and yes, we have a haunted random number generator. We have unmarked chips from a long time ago in storage, which might possibly be the Kuji EK1 I Ching engine, or I Ching engine. So we might want to experiment with that, because, like, if it is what the thing that's in the documentation, then that that's an entertaining bit of background music. Then it might have two simple I/O connections, one of which is labelled button, and the other of which is labelled Oracle. And while we have lots of exciting things about how it manages to generate to actually do I Ching with yarrow stalks inside a chip at very nanoscale, it's going to need it may need some experimentation to prove that that's what it is. So I think we may want the music on the television a little quieter. Right, so I think the first thing we want to do is look at verification. So that says that's better. Thank you. That we have something. Well, I suppose we could just try running the thing and seeing what it does. Okay. So
Enough for breakfast.
yeah. So that doesn't show us where the signal's coming from, but let's just try wiring that up to P0 on our processor and see what happens. Oh well, that looks quite good. So this just appears to be does genuinely appear to be a random number generator. Excellent.
Is that safe for laptops?
Yeah. So this may be utterly. So this is mostly utterly trivial, except of course we need some memory. So our sound effects. The plan is it should emit sinister giggles and blood-curdling cries. So the sinister giggle is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 things long, as is the blood-curdling cry. So conveniently we have 14 element ROMs available to us. So we could have one ROM programmed with each sound effect. And then I probably want to put these on the same virtual desktop. Oops. And then we can have a convenient sentinel at the end to tell us when we finish reading each ROM. So how does it go now? 74, 54, 27, 74, 54, 27, 19, 40, 75. Right, and the other one is the blood-curdling cry, which goes 16, 36, 42, 14, 10, 58, 28, 70, 80, 42. I've already forgotten it was 80, wasn't it? Yes, I just got slightly worried. Right. Okay, so that's the two sound effects, each programmed into a separate ROM. Now the problem is that the ROM has an address and data port, and we need to connect both of those. We need to connect them up for both ROMs. So I think we actually go for the MC6000 because it's got 4 XBus ports, so we can wire up one ROM to each XBus port.
You don't have an indirection that says load from whichever Xbox port I happen to feel like today.
No. So we're going to have 2 readout loops. Again, TIS-100 does this better.
Well, I mean, you could have a
Oh, what?
test that minus move from here, plus move from there.
Yes. So that saves us 1 instruction for sharing a jump, or thereabout. Oh no, it gives us the right as well, doesn't it, and the sleep. Yeah, okay, that's probably worth doing, isn't it? Given that we've then got that spare register that we're not otherwise using. I mean, that certainly looks like a reasonable bit of layout. Justin says, I assume the width of these ROMs doesn't permit putting the other sample in high bits or something. Ooh, we don't have a division function, and we only have digit extract. And the problem is these are mostly 2-digit numbers, I mean, apart from the 100. And everything will only go up to 999, so I think we can't quite cram 2 samples into each cell. Obviously, if we had a divide by 100 function, rather a divide by 101, maybe that wouldn't be quite sensible. Then we could do this, but we don't have division. We only have multiplication. And yes, we can probably implement division eventually, but I don't think we can do it in a small number of instructions. So I'm going to go for the slightly brave assumption that the incoming values are positive integers, and therefore it's going to it'll turn out to be a mess again, because whenever you try to use TCP for this sort of thing, you go, God damn it, I want an if equal flag, and you only have an if greater and if less flag. We might be able to do something, but yes, okay. So then, if it's, yeah, no, that's just going to be infuriating. I'm going to do this the crude way, and then see if we can make it cleverer later. So if it's greater than 2, jump to the end of the loop somewhere, and we'll put a label in for that in a bit. Right, and then we can go, if it's, so then we go, if it isn't 2, i.e. if it's 1, then we go mov x0 p1 mov x2 p1, that's not an x, that's an x. And then the pointers will automatically advance, but the slight problem is that actually we wanted to check whether that was 0 at the same time. And it's meant to reset to 0. I'm slightly confused by the way that the speaker output is meant to be positive and negative. Oh no, it's not. The horizontal line is just in the wrong place. The horizontal line's at 50 for extra fun. All the numbers in the second sample are even, but that probably doesn't help. Thank you. Well, so that means we could divide them, but they're still rather big. So the problem is actually I think we need to move to ACK so that we can check for reaching the end of the sample. Because we're depending on the auto advance of the pointers in the ROMs. So then we go if ACK is 0, jump to the top again, or possibly jump to the end, because we actually yes, that probably well, we'll see. I think I'm making a slight mess of this anyway, because I think the loop has we have actually an inner and an outer loop that we need, and I need to think about them a bit more. So, but the thing is, actually at the end it wants to. Are there any 50s in the samples at the moment? No. Since 50 is what we want the output to idle at. Let's stick a 50 at the end of each. ROM and make that teak ACK 50, and thus actually mov ACK P1 first. So now we then end up wanting at some point a slup 1 and then go back to the readout loop, which is here. This is why I keep ending up writing my labels as single characters, so that they fit nicely. And then end ends up being slup 1 and then loop round to the top again. So I think that's not actually catastrophically wrong now. So shall we just try hitting simulate and seeing what happens? Right, so apart from the fact that it starts incorrectly, so the only issue is that it actually needs an initialization step where it does mov 50p1. And we could use our magic initialization flag. Actually, yes, that'll save us a small amount of power, won't it? And success! We have a haunted doll. So, how is this going to turn out very badly for poor Joe?
One fewer line to
Well, it might be further down than that. It's hard to tell. Because this is those are buckets. They still don't know where it came from. Then what is the point? Believes that Ghost Electronics have a potentially very bright future in the marketplace if you can work out a way to sell them. Except that Lily has told you to stop because apparently working for the military is better, or at least more profitable. Or is it Ben dropping his laptop because I wanted to move it? Seb says Joe's angling to start a cult. Aha, yes, of course. Cults can be profitable, can't they? Joe is just seeing further ahead than the rest of us. We are still creating multiple products with no point, no goal, and no larger plan. Though I believe Joe has a larger plan. I want everyone to think about how to focus on products that have the potential to truly change the world. Where are the devices that we feel proud of as a company? I know which jobs you've been bringing in. How can we earn respect? What future are we building towards? We must face these questions head on and with all of our efforts in order to have a chance of becoming one of the world's top electronic firms. My uncle named the company Long Teng Rising Dragon for a reason.
Do not despise the electronics company for building cheap tap, but who is to say it will not become a rising dragon?
Thank you. Or maybe we want to build a maintenance robot then. Surely many of you have heard of Sun Hao Tian. His father was one of the first electronics entrepreneurs from this area, starting from when it was first designated a special economic zone. Now that he's inherited the family business, it would be no exaggeration to say he's the most powerful man in Shenzhen today. An opportunity has arisen to work with his conglomerate on a device that moves between stations in a line. Apparently it's intended to serve an automated aquaponics facility. It's a small start, but understand that our relationship with him is absolute top priority. If he feels he can trust us, we'll continue to get bigger and better work from him. So, I'm slightly suspicious of the probably, and we don't quite know what this does. Tool clean and tool feed are simple outputs connected to unknown tools. Soylent Green Maintenance Bot, says Justin. When a data packet is received, move to the destination and activate the tools for the specified durations. So we receive a three cell data packet, which tells us where to go, how long to spend cleaning, and how long to spend feeding. Well, that feels like it should be pretty simple. The only slightly tricky thing is remembering where we are. But since those are two simple outputs, we could use the pulse generator instruction for that. We need three simple outputs because we also need to operate the motor. But the motor we could do without a pulse. No, but then we have to. No, that's fine.
That pulse generation instruction must require an entire micro instruction engine somewhere in the back of the
Yeah, but when it turns out that 90% of what the processors you sell do is making little pulses, it's probably worth it. Maybe. But I am slightly worried because that means we need to remember where we're trying to go and where we currently are. And we can't reread where we're trying to go from the radio because the radio will only tell us it once. So maybe, infuriatingly, this either needs two processors or a big processor. Or to stick an entire RAM chip in, but that's the same as the difference in price between a small processor and a big processor. True. Well, kind of. It takes a bit of faff to get the data in and out, so it probably actually consumes more power because it's number of instructions executed, really. So mostly we're buying the big processor for the DAT register. So if we go... that's the extra problem. Oh, hang on. Maybe we do need some RAM. Because we have to record all three numbers from the packet somewhere. And we have to do all that before we have to record all of the positions before we move the robot. And we can't store three numbers plus our current location in two registers. Well, we can, but really we shouldn't. We can. Maybe we should. Let me read the... because each of them is only a single digit. But we don't have enough space to stash them. I don't think this can be done without either more processors or some memory. But I'm kind of inclined to go for the more processors approach in that case. Though that might... because we could have RAM and then we store the entire packet in there and then rewind and read the packet. That might not take very long, actually. Let's try it. And we also need two. We're also going to need a DX300, at which point we may as well throw in a second processor. And surely a second processor is going to be less confusing than memory. As if we go for having... something like that, then essentially our first move is something like not B, wrong processor family.
I mean, you've got ubiquitous conditionalisation, it's an easy mistake.
Yes, I've got a fly in my tea.
Don't worry, it won't do much.
Right. So then if it's not, then that is the position that we're meant to be moving to. So then we should do mov ac x3 to tell the motor processor, which is going to be the one that keeps track of where the actuator is, where to go. Then we need... so then we receive clean and feed, and annoyingly we want to operate them in that order, but that shouldn't be... that's not too much of a problem, is it? We go... it's kind of infuriating because... yeah, because then I go x0 oh no, we've moved that in, the cleaning time into ac and the feeding time into dat. Actually, maybe we don't even have to do that because we can use gen now, can't we? We go gen...
I keep wanting there to be a second data register alongside that called dis.
Gen P1 P1 AC 0 Gen P0 dat 0, so we don't even have to count down or anything, and then we loop back to, then and then loop back to the top or something. We'll see if that I may need an extra sleep somewhere or something. So this one's job is then wait for an input on x0, so So, how are we going to handle this then? Can we do this with only one register? Ugh. Not sure we can, actually. But, like, conveniently, because, because we need to keep track of where we are, because we're only going to get requests as telling us where to be, but we also need to keep track of the current request, and we actually have to, the other processor actually has to wait for us to get there. So I think we need to do something stupid.
Yes. Just needs some distance in past.
That's not going to work unless I move that processor up a bit. So I think what I thus want to do is to have the main processor repeatedly transmit to the motor processor where it wants the motor processor to be, so the motor processor doesn't forget that, and the motor processor to signal back whether it's got there yet. Because the main processor has to wait for this to happen anyway, so it may as well be involved and act as the other one's auxiliary memory, except that that doesn't work because we have to read the entire packet before we can do anything. And that's used up all of the registers in the main processor. Gosh, do we need a big processor for the second one as well? Getting to the point where I would be better off doing this with some extra RAM. Right. Oh, and let's assume we do have to sleep at the end then. Right. So then this one is wait for something to come in on X0. Remember it. This meanwhile will wait for something to come in on X2 and throw it away. Then this one just does sensible use for TCP, maybe. TCP, we want to check dat against ACK. So if we need to go left, then we do generate a pulse on... Oh no, because gen is only goes to... No, we can't use gen. We're going to have to do this the slow way, aren't we? Also, we need to start with a... make sure the motor is off at the beginning. This probably doesn't work because we'll end up sleeping too long. But let's see. It might work actually. Let's write the full version for now actually. Right. No, there's an awful lot that ends up shared, but isn't shared with the equal case. Which I think makes me... Maybe we just stick in we make that minus mov 0 p1 plus jump whatever second half of pulse thing p minus jump p, and yes, I probably shouldn't interleave those, and then at that point we're somewhere down here. We then have p slip 1 mov 0 mov 50 p1 slip 1 jump L. No, maybe L's a little bit too. Okay, and that would then be there, and then otherwise we're at a situation where we've hit our target, so then we go mov null x1 T for top, which actually means we don't need that out there at all. So it can probably be done prettier, but it might work correctly. No, doesn't work correctly at all. Excellent. It only seems to have read 2 of the 3 bytes of the input, and then it just drove the robot all the way to the right hand end of the track and kept going. So the first step, it did the right thing. That bit was correct. And then that's ended up where I expected. And that is set to do. We don't increment the accumulator. We don't adjust the accumulator when we move the actuator. We need an add 1 or sub 1 AC in here as appropriate, which is kind of unfortunate given we don't have any space. So like, if for now we pretend we never have to move left, then that, I think, would get the rightward movements correct. Yes. So, like, we're not doing badly there. We can now move to the right, but we've run out of sorry, just reading the IRC. Right, so, oh, sorry. So that works, but the problem is we need 3 extra instructions to support moving left, and we have no space for extra instructions. So, but actually we can oh no, we can't simplify this because that needs to go to presume we are only allowed 1 condition code per instruction. With plus or minus, which at least does not appear to indicate that we can have both. So if we turn that into... So I think we save an instruction by switching... by going... and that is obviously where label K goes. Hang on, that's ended up the same length as before. That's because I've still got... No. Okay, that hasn't actually saved us an instruction. It's ended up the same length as before, but less confusing. Kind of this... The way that we have to generate these dual polarity pulses is kind of annoying. Because then we want that and a minus sub 1. And we don't have a space for the minus sub 1. So, I mean, I wonder if we can do a silly trick of initializing this thing weirdly. Oh, yes, I think that might work. So, this is currently wrong in that it starts wrong. Everything else is fine. It's missing the initial don't go anywhere on the first step. It tries to... I mean, in terms of the robot's movements, it's fine. It tries to move one step to the left, but since it's at the left-hand end, it goes clunk. But apparently going... I mean, this is obviously what you do at startup. You drive hard to the left, and thus you know where your actuator is.
Also, you pick up the egg to the left of the starting position in limbos.
Quite plausibly, yes. But sadly, someone has insisted that the system knows where it starts and doesn't drive hard to the left when it starts up. So... But the thing is, I wonder if we can do something silly, like... can we then arrange that when asked not to move, the actuator moves to the left, sets its output to 0, to 50. Problem is that involves jumping in to the program there, and then it will sleep 1. Is that safe? No. I mean, that would then, if we were to somehow arrive there, that would actually, I mean, we'd sleep 1 at the beginning, but that's fine. We've got 1 step of time at startup if we need it.
Well, I mean, this program never restarts from the beginning, does it? It never makes use of the...
You're right, it never falls off the bottom.
So you could just move those 3 instructions to the top and reorganise something.
And then, well, we'll have to change slightly what the left processor says to it. So, actually, maybe we don't. Then it'll jump to there. That will then test for equality of ACK and DAT. They will be equal.
And now when it falls off the end, it will go back to the top, which is the same.
Yes, I mean, we've just rotated the program. That will then try to move something to X1 and then jump to T, which will then be waiting. So all we need to do then is add an instruction here that does mov X3 null to absorb the I am now in position message from the right processor. So I think that should do the trick. Yeah. No, that's loop 1, of course, is a problem. Let's just be a bit silly about that. That one can also slip 1 at the start. Okay, why have you jammed there then? You're writing to X1. Oh, because I read from X2, idiot. Right. Oh. It's crashed. Oh, because the other processor did rely on being able to fall off the bottom.
Oh, so there's rats.
Yes, actually, that's fairly simple, isn't it? Right. Right, I almost pressed Control X, Control S there. Hooray! I'm kind of intrigued by, well, actually at the high end of this, how did you fit it on? How do you fit on something that costs like 25 yuan? 25 yuan is 5 processors.
What do you count? Five big processors.
Clearly it's part of a much larger project, but no one I speak to will say anything more. So yes, our Soylent Green is another bit of spam about own land rich in rare earth metals in the western region of China.
Transuranic heavy elements shall not be used by those life.
Don't think they're quite transuranic, really.
Good job. Go in China. Rumour has it there's life there.
Remote kill switch.
Are there any more elements than the things further out than this? So you get neptunium and plutonium.
Yes.
Are there others? Are they therefore the only two transuranics?
So we now have. We would like to have a remote kill switch for autonomous systems. This is in case of failure of the autonomous system. Of course, such a switch would not be needed if we always design the systems correctly. We should make this. I will create the transmitter and you will create the receiver.
Well, every 76 years you get the Halligans.
So this one involves reading a packet and then turning on or off a one of the 3 outputs depending on what the input is. So that's one of our. So that's the new challenge, or we can go back to thorium mining, or infrared sensors, or carbine target illuminator. I think the remote kill switch sounds fun, so I think I'll do the remote kill switch unless someone has a better plan. So, obviously, 3 simple outputs says we want one of those. And then essentially we just want a register that says what state those are in and flips them accordingly. Which might mean... So what's going on with DST, set the digit of act specified by the first operand to the value of the second operand. So, I mean, I'm wondering if we can actually just do this with your basic MC4000 for once. Though it might be a bit mad. So all the power outputs start off low, so that's fine. So the first instruction tells us what to do, and it's, as usual, an infuriating thing that doesn't quite work right with how TCP works. But that's not too bad, because it's... Okay, yeah, we've already run into the point where we have to... well, maybe we can do it with TCP. Let's try it. So then, no, it's going to want another register, isn't it? Curses. I hate this repeated requirement for a second register. Because what we need a register that contains the current state of the outputs, so that we can turn things on or off. And then we're going to need... We need to... Well, I suppose at the moment we've got which way we're going in the condition codes, haven't we? Maybe we can do this. So maybe we can go... If we've been told 1, which is turn on, we digit set... the next thing we read from the X bus, because that's the which channel it wants to switch, and we set it to 1.
This is the kill switch?
Yes. Yes, this is the kill switch. Or rather, at this moment, the unkill switch, in that its job is to turn things on. I haven't written turning off yet. And then we jump to E. Otherwise, digit set... not X... Yes, digit set... and... mov ac x1. Otherwise, digit set thing to 0 mov ac x1. Well, that looks good to me. This is clearly a solid piece of safety critical software. So we say if it's negative, we just wait, i.e. either if it's minus 999 or minus 1. If it's otherwise, if it's positive, we read from x0 and set that digit to 1 and write out to the outputs. Otherwise, and then jump to the end, because otherwise we'll do the same with 0. Right, I think that's good. Oh dear, it doesn't quite work. Oh! I think I'm missing an instruction. Turn off all power outputs when 5 or more time units have elapsed without receiving a data packet. I completely missed that bit of the spec.
That's the remote kill problem.
Well, that's the watchdog. Make sure it dies even if it's not killed remotely. Well, oh.
This is where you frustratingly have to upgrade the processor.
No. That's no fun at all. obviously that's clearly a separate function, and for safety critical software should be implemented in a separate processor. We insert this processor between the radio and our main thing, and this one just counts. And when it hasn't heard anything for a while, it fakes a turn off all outputs message.
I think at the point when you're inserting an extra processor on the circuit board, you move beyond the realm of safety critical software into the realm of safety critical hardware.
Yes. The only problem is that there isn't actually a turn off all outputs packet. But otherwise, I think this is a perfectly solid piece of design. So we may have to work out how on earth we're going to turn off all outputs. Especially when we only have one instruction spare. Problem is, as soon as we read something, we throw it away. And if we're going to have a counter and, damn it, if we're going to have a timer and be able to actually look at our inputs, I think we're going to have to buy the big processor. I hate having to buy the big processor. It always feels like I'm, giving up. I mean, it is also cheaper, of course. Let's just check that still fails in precisely the same way. So our problem here is that we can't do arithmetic on DAT. And we can't swap ACK and DAT. We end up throwing them away. Oh gods. Is there actually a sensible way to fit this into one big processor anyway? Maybe we need a big one to do the safety grip, to do the timeout detection, and something to do this. Surely not. Because we can't. So if we can have DAT. Yes, we can morph things into DAT, but that's not very helpful. Because we can only morph them from other places that exist. Yes. And in particular, we can't we can't do any arithmetic without moving to the accumulator, and that trashes the data we've got in the accumulator. So now I'm going, oh god, do I need a big processor to do the counting and a little processor to do the flapping? Actually, let's change that SLUP1 to a SLX X0 and see if that works. Actually, let's test that first. Let's not worry about that processor. I think it doesn't mind about processors that have no code.
Oh, does it complain vigorously?
Oh no, it whinges that it never sleeps. Okay, there we go. Oh, that part's not sleeping, you say? Because it does SLX X0 and there is always something to read from the radio. Right. But we can arrange that there isn't always something to read from the other processor, of course. Right, yes. Okay, back to what I was doing. Because we don't actually have to simulate the radio precisely here. So if TGT Act 4, please. If things have gone on too long, then we go. Vast spam of open coded stuff, but and then in the other case where we actually want to carry on transmitting commands, and this will not work for at least 4 different reasons. Well, no, not quite 4. So the first reason is that I can't remember how I've wired it up. Right, good. So now that one's the only one that's sleeping, and that's because this has moved the wrong number of instructions because it has to So I think when that receives a 999, that's when it minus 999. That's when it should sleep, because that means nothing more coming this packet. Oh dear. But that's then
Yes. CK3 is a bit annoying because it's kind of like CK2, and in many places the sort of skills in that cross over, but there's also a whole bunch of things that are just like I don't quite understand them and can't work out what's going on.
What's the... I don't know quite how to answer this question. In game series that deal with fictional things, there's usually some fictional reason for needing another game. Like you're following on the life of the same character, you're following a different character.
Often it's
But in Crusader Kings, what's the...
that you've improved the game engine, you've made it.
yeah.
Right, but that's a joyless reason, it's not a what's only reason.
Yes.
Yes.
But
Yes.
so for games like this, that's the only reason you're going to get.
Yes, it's essentially, it's 10 years later. We can make it shinier. We have I think actually, from what I've read of, mostly of John Bull quoting and discussing things from the Paradox developers, it's essentially our old game engine and all of the stuff we've layered onto it are getting too creaky. We need to rebuild it from the ground up. Yeah, and possibly we can also thus throw away some of the rules that we decided. This is an opportunity to thoroughly revamp the rules. And remove features which otherwise you probably can't get away with doing. Right. Well, that piece of insanity still doesn't work. But it works no worse than the previous version. It's just that up until the watchdog should have fired. So my extra processor has gained us 0, but it hasn't lost us anything. It's sitting there successfully passing things through. It's just it goes horribly wrong at some point. So like AC is correctly counting up and getting reset. So then it reads another minus 999, transmits that on, adds 1, waits, that's fine, checks whether it's getting a bit late. It is, so then it sends a -1 down there. Okay, my major problem is I'm not sending the correct commands to the control processor. I send it the everything's fine signal, not the please turn everything off signal.
I was going to say, I mean, it ran fine up to the point where the entire next 6 lines of code trigger, so there's plenty of scope for possible fixes with just those 6 lines of code.
Right, let's have it send zeros instead.
run up to here, please.
There is an option for that.
Alright, then, you don't.
All mechanics are just subtly different in the way they're very
Right. Well, I think there might be some scope for some more efficiency in that one. Possibly the having two CPUs in parallel, but with every command passing through both of them.
is suboptimal.
Like, I suspect you could do better by having this one just be poked occasionally by this one, rather than seeing every command as it goes past, and then sending back a now is the time to turn off. So, like, I quite like this for its, I don't know, the design of interposing one processor. So,
Some electronics engineers might interpose processors for their
3, 4, 5, 6, 7, 8. Surely that'll fit in an MC4000. Yes. And we don't use DAT at any point in that processor. Oh yes, I was going to say, I think Control-click applies a breakpoint at any time in thing. So we could stick a breakpoint there and then go run, and it will run up to there and then pause. Right, that's a bit cheaper. Yes. But this is a kill switch module for a large industrial robot or something. It doesn't matter that it's not using negligible amounts of power. I kind of trust the code at least. I am learning some more casual style English from Joe. Yes. Oh God, hello David. Mems, Yarrow Stalks, I think we have to. Summarise what the emails say. Okay. So the one regarding the remote kill switch is simply Zhang-Ji says, "Sweet, can't be too careful when you're making robots. Am I right or am I right?" Brackets. I am learning some more casual style English from Joe. Carl, you scared me for a second there. So the two new jobs are one from Lily, who is our contact with probably profitable customers in the military security services, whatever the hell it is that Mr. Sun is doing, who last provided us with the job for the robot that moves left and right, which wants a simple data router for smart grids. Mr. Sun was never interested in civic infrastructure before, to my knowledge, so I really wonder what he's planning. I may ask around. My uncle's had dinner with him once or twice. Lily Wu. From Zhang-Ji, just, we can do it. Those X-bus inputs are blocking, so we will need to connect all inputs so that they can be read at once, brackets simultaneously. And the Pocket I Ching Oracle, we have David being his all person who knows far too much about Chinese culture. I've noticed the I Ching experiencing I Ching experiencing a resurgence in popularity lately. Let me briefly explain. A hexagram is a set of 6 lines where each line is either solid or broken, with a total of 64 possible combinations. There is obviously much more to it, but I don't want to go into it too deeply. I have been studying the method for a while now, but I wish that there were a quicker way to generate hexagrams. I thought perhaps this ancient divination method could be brought into the modern era somehow as a pocket device. Carl is immediately, so 6 coin flips is it then? No, not at all. Much more complicated, much more detailed, involves yarrow stalks, act. I stopped by to try to describe it to you, but you weren't at your desk. Suffice it to say that we will have to generate the readings in the proper way if it is to be taken seriously as a divination tool. Zhang Ji, I found the part that works for this. It implements the physical yarrow stalk method in miniature (mems). Strange. So we can just create a display for the result. Obviously the interpretation is up to the user. So, yes. Because somewhere in the datasheet there is miniature I Ching oracle. Here is our miniature I Ching oracle. Button and in oracle are simple inputs connected to a MEMS-based oracle engine. Display is a display output corresponding to a custom LCD screen designed to visualize I Ching hexagrams. When the button is pushed, the oracle will generate 6 values corresponding to the 6 lines of an I Ching hexagram. When the final value is generated, the display should be updated to match. So we get a button, and simultaneously the first of 4, 5, 6 bits of simple input. And once we receive the 6th one, we should update the display instantaneously to show all 6 outputs. So one slight question is, how does the display work? We have a documentation for displays somewhere. So no, that one has 6. Are those 6 simple inputs? They're not marked with a dot, which suggests they are simple inputs. Let's just build a simple test, actually, a test circuit here and see. Right, so yes, it does look like our right joy. If we do it that way round, well, I suppose actually that depends on quite what we consider to be backwards. So what happens if we just... we're surely going to run out of... we're going to need 2 registers for this, so... Big processor. So then we do something like that, so that we wait until someone presses the button. Right. Then at this point someone has pressed the button, so then we need to do something like digit set 0 P0. I wonder if that works. It's a shift register. You cheat by using some spare encoding space in the register that the demux doesn't use, so you can loop around doing the shift register twice. So that might work. So the we may need to experiment with what the demultiplexers can do. I'm going to see if my trick works first. So that should now read the entire first 3 bits. Okay, it doesn't. Because it looks like if your digit is 100, that doesn't get into our usual saturating arithmetic doesn't apply. Right, okay, my trick doesn't work. Let's look at Ian's trick. So his idea involves something like mul 10 add. We can't just add P0. Oh, P0, because P0 is going to be much too big, though. I mean, we could do something like TGT P0 50 plus add 1. Slip 1. I mean, obviously this will fail in new and exciting ways, but L for loop, D for digit. Right, so this won't work. Hello, Eek. Are you going to bed, Eek? That's a very noisy place for you to go tap because that's the microphone. Good night, Eek.
Yeah, so what does the demultiplexer do if you send a digit that isn't either a 1 or a 0?
Yes. So that shifted the first 3 bits incorrectly and then incorrectly, and then all went horribly pear-shaped as expected. Okay, let's do some more experiments. What happens? Because if we could, for instance, interleave the bits somehow.
I was going to suggest that if you have 2 shift registers and every bit you receive, you shift it into one of the registers and swap them. Then you end up with one register containing the even bits and one containing the odd bits, and then all you have to do is...
Yes. Wouldn't it be lovely if this processor had a swap instruction? I don't think it does. This is the thing I really miss. The TIS 100 similarly has two registers, and it has a swap instruction. And this is so much more useful because you can actually use both registers.
Well, I mean, you've got add and sub, right?
Yes. Do you?
There is an add sub version of that triple XOR trick for swapping in place, but it does use 3 instructions.
Does it depend on wrapping behaviour, or will it work with saturating arithmetic?
I think in this case, none of your variables are close to out of range.
Right, yeah, that's fine. I mean, I thought it might be that it nonetheless depended on it, but I suppose you probably can't generate anything that's out of range with that just add and sub in 3 instructions, can you? No. Count up to 3 in DAT. Remember, we can't do arithmetic on DAT. And we can only do add and sub to the accumulator. Similarly. So we can add DAT to accumulator with the result ending up in the accumulator. We can't add them together with the result ending up in DAT. The only way we can get data into DAT is by MOV. Which means that which in particular means that after that instruction, ACK and DAT must be equal. Which means we must have lost information. Somehow. Now, it might still be...
You think that's bad. You wait till they bring out the quantum computation version of this, in which the no-cloning theorem will prevent you from throwing away information, even when that's actually what you wanted to do. Which theorem? The no-cloning theorem.
So, let's experiment with what these things do when you feed unhelpful data to them. So he said 1, 2, 3 to that. And it interprets that as 1, 1, 1. So any non-zero value, okay, we've only tested up to 6, but is treated as 1. So you can't, which is almost certainly a useful fact, but not something we can immediately do something with. And we immediately then get a test failure. So, and we have to trigger at 6 pulse or 6 input signals, even if the last one is 0, which means there isn't any like sentinel we can use. So yes, the not being able to do arithmetic on DAT is a pain. So so that bit worked. The let's go back to the digit version, just version. So our problem there was sorry, P0 in all cases. And that should be just 2, you idiot. Was that setting digits to 100 doesn't work. I wonder if that's documented. No. So, I mean, we could do some trivial signal conditioning. So the tricky thing about the shift register approach, is that we need. Let's try. I mean, let's just go for the stupid thing of an entire processor whose job is signal conditioning. It's not like we haven't built one of these already. So, we don't like the fact that our inputs come in as 0 and 100. Let's turn them into inputs that come in as a 0 and 1. Because obviously, detecting these tiny, like, millivolt swing in this line will be fine.
Well, I mean, if you want to be nicer about it, you could turn it into nice digital stuff and put it out for an Xbox port.
Yes.
But whatever.
I have a feeling we may have a needed NOP somewhere. Because that ends up happening at the wrong time in short time.
Is there a
Yes.
no?
I think they do document what it actually expands to. No, they don't. It's not expanded here. Probably MOV null or something. It was something odd like add 0 in TIS 100 officially. Yeah, so we still have the problem that this processor is too slow. So obviously we should do it with XBus because that will force the synchronization. Actually make it X1 because that's easier to wire to. Oh, except that doesn't work because now nothing's reading from. Yeah, the problem with that is that now all the synchronous stuff becomes a pain. So then we need to have a MOV X1 null there in order to absorb the input. Sorry, MOV X0 null. So that works insofar as we actually have to jump over that MOVX naught null now. That works insofar as we correctly load the first 3 bits into a register, but then we're going to need to swap that into DAT, do the same thing again, and remember where we were. And remember the fact that we've now loaded both registers, and then squirt both registers out down the output pipe. Is there another approach? I mean, obviously there's another approach. Would it be a better approach, actually, to take advantage of the fact that these are simple inputs and have one processor driving each output
I was going to
unit?
suggest that, but I thought you wouldn't like it.
Well, it might work.
I mean, an obvious thing, an almost obvious design would be to have one processor reading the oracle and alternating which of 2 X bus ports it spews each output bit to, and then you just need each processor to collect 3 bits and put them on the bus.
And then do all the fiddly stuff in hardware.
But the problem is that if the first processor is just alternating strictly, then who reads the button? And you need to work either of the other processors could be the starting one, and so you need to synchronize them in some way along those.
Why are you doing that, Ben? Yes. Um, right. Probably haven't got enough space to do this all here. So then one of these,
Oh, of course, you can fan out inputs. Good point.
yes. So the bottom, the top one then has to just slip 3. While the bottom one loads three bits, which may actually be a pain because they're going to come in as 100.
Do your same previous dodge of having an initial translating processor
Yes, P0.
at the right end of the fan out.
Yeah, that's slightly trickier, but so we need to do that 3 times, which we can't sensibly open code. Yeah, the problem is that it takes too much faff to load these. Yeah, so Diz has now suggested can have a timing signal conditioning preprocessor which counts to 6. I think something like that is probably our best plan. So it doesn't try to store any information, but it instructs the others what to do.
Oh, microcode interpreter.
Another thing, I keep going on about TIS 100 and how much better its processors are, but they have this brilliant instruction called JRO, Jump Register Offset. So, given a register, add that to the program counter. Perfectly ordinary instruction. In TIS 100, the registers include what are very similar to XBus ports. So you can go JRO this XBus port, which means you could have one processor sending jump offsets to another, and the other one just has a program that goes JRO input, and then a bunch of little routines that are things that it can do, each of which ends with a jump back up to the start. And thus, you essentially end up with a chain of processes, each one of which sends a sequence of instructions, generates a sequence of instructions for the next one down the chain, gradually getting simpler and simpler.
I guess this is what you get for working for a company that wants to be the lowest bidder. This 100 presumably costs like 3 times as much as an M6000.
Yes.
Anyway, good night.
So yes, we would love to have that feature, but yes, maybe we can do. If we invent something whose job it is to not actually try to generate the outputs or even remember anything, but just handle the inputs. Obviously, we need a bit more space than that, don't we? We're going to need somewhere to put the other processors. Actually, can we? Yes. So then this one's job is to go that can happen a bit later. Yes, you're quite right. 68,000 mode. So that's the signal conditioning bit. It can probably be done a bit prettier. Then if the accumulator is less than 3, then send it one way. Otherwise, send it the other way. and then actually, here's a particularly silly manoeuvre. That might not be helpful, but it's cheap. As in, just send the current count. They can, the other processors will need to do a compare anyway, so they may as well do the actual counting compare for us. Does that help? Well, it probably doesn't help much. So then the idea here these may be able to be made smaller later. Damn it, you can't actually wire in that close. I mean, we're not using any of this stuff over here anyway. So then the idea is that's not very helpful, that has to come later. unroll this. Diz says unroll this loop and it becomes simple and will fit in a 4000. Possibly. I mean, I think this may fit, but I don't know that I need to unroll it. I think this works. Maybe it doesn't. Let's see. So the idea is every time we go around the loop, the input processor sends us the current count and we check it, and then we either multiply by 10 or send the output and clear the accumulator, depending. And yes, I think that does more or less what I want, but I'm not sure. we're missing a critical thing here. We never increment the accumulator. So I think this processor's instructions are a pile of rubbish. Yes, they are, because actually that should... Oh, gods. Yes, I think this wants to send either an instruction... We want to have things that say... The first thing that comes in is, what of the two things should you do? Should you add and shift, or should you display? Yes. So I want... wait for an input. Rather than adding it, do... say, let's just go for, is it greater than 0? If it is greater than 0, the next the next thing, no, if it is greater than 0, then display mov ac x3 blank the accumulator mov 0 ac. If it isn't, then add, then shift and add. With the next thing that comes in. That seems a much nicer program. Right, now how can we drive those? So then what we say is, if we're less than 3, we send to x2 1 followed by the thing. Otherwise we send that to x3. I'm still slightly worried we're not going to have enough program here. Oh! I think I've understood what you mean now. I think. So you'd say that the first... So these would instead go... The problem is we need 2 instructions for each input. So we would end up with something like... Because we have to do an SLX followed by processing the input. Though I've just thought of a way we could avoid that. So we'd need something... And can I just check whether I have enough space for this? If I then go... And then my problem is that I use sharing this slip between 2 different loops and we don't know where to jump back to. Right. Okay, let's try your... Okay, so now... Well, the input processor does need to know when to stop, of course. Because it needs to know when to start listening for the button press. So if we go, so is the idea, let's leave that as it is and rewrite one of these. So I think Tiziat's idea is that this goes, so this one is the first processor, so this one takes the first 3 bits. We're within one instruction of it all fitting in. Because of the need for all these SLXs. Because now, my next instruction is going to then be MOV ACK output register. But I don't have to do it in this order. We don't have to do add mul. We can do TGT, DST, of course. And that saves us an instruction each time. I can't slip 3 because I have to keep reading from the X bus. If the input processor doesn't know which direction it's sending data to. Well, how do you propose that the input processor decide which output processor it should be sending data to? It then needs a bunch of conditionals. Unless you... I suppose it still needs the conditionals. So is it only one test? Yeah, maybe this will work. So essentially, we can there, the idea is we do that. Is that right? Except we probably don't need that bit at the bottom. And then that, rather than waiting for 3 inputs, does slip 3. And then that's exactly the same, except it doesn't actually need the slip 3. We still need to increment the accumulator. Idiot boy. That's doubtless unnecessarily complicated. But yeah, okay, it helps if I get the instructions right. And that generated the correct output even. We've got the things in the right order. Right. I'm going to flip that round to LT Act 6 because I feel more comfortable that way. Right. Oh, then it fails. Right. There's a bug somewhere then. The problem is actually not that with that change, so I'm going to remake that change because I think it's more sensible. Plus. Because that works fine as far as actually generating that goes. Then it's polling for the button. The button press happens. And no, that should be fine. So actually, let's just pay attention to what happens, what state those processors are in when they're waiting here. Why is that one waiting there? It's received a signal it shouldn't have received, it looks like. That looks like that goes round. That thing goes round the loop once too often. Well, clearly I'm using off by one error. Let's try adjusting our loop counter. Right, that's better. Right, now let's. Oh. Try not to throw the other laptop on the floor. Right. I feel that we ought to be able to reduce the input processor a bit, but on the other hand, we can't reduce it by much. Yes, it would help if we didn't have to keep renumbering the X-Bus ports. Like the MC6000 should be a superset of, or the M6000 should be a superset of the MC6000 should be a superset of the MC4000 rather than offsetting everything by one. Right, that's reduced the price a bit. So the alternative design would be to throw out these two and put in another processor. No, that would increase the price. Yeah, I suspect the control flow in this first processor is unnecessarily tangled. I mean, like, actually, just to make it less horribly unreadable, I should probably move that sleep up to here. Like that at least is less horribly unreadable. It's no faster, but at least you can see what's going on now. Just going, is there a cleaner approach to any of this? If only our yes, well, if only DST did something more useful, then we could DST bigger thing. We could do a similar trick here, but if we could do that, we could have done it in the end processors. Yeah, I can't see an easy way, an obvious way to make that any shorter. So that will have to do for now, I think. So, David, splendid, how wonderful that such advice was created right here in China where it all began. I'll probably even use this oracle myself as Xiao Mei and I approach our wedding day. From Shangji, David is more Chinese than even a Chinese person. David completely fails to notice the sarcasm. Yes, thanks. From Tilly, whose comments about cheese led to my choice of opening music today. One thing I always tell people who come through Shenzhen for various reasons is to check out all the electronic parts markets in the Huaqiang region. It's insane and super interesting, even if you aren't here for electronics at all. Imagine your traditional Chinese wet market, bustling with activity, hundreds of stalls bursting with everything you can imagine, except everything being exchanged is electronic parts. Substitute the smell of fresh solder for frying oil. Think of digital trash littering the streets instead of food scraps. And it's not just a few parts, okay, but every type of every part. Like there are entire markets dedicated to insanely specific things like batteries, say, or LEDs. It's a continuous white-hot exchange of every manner of anything electronic. And craziest of all, these guys represent manufacturers who are also right there. You could find a part from a dude and ask him if you can supply your company with 1 million of them later the same day, and they could. It could happen. I try to convey the scale of that kind of thing to people who haven't seen it, and it just doesn't come across, you know. Oh, a market, that's nice, is what people would say, especially back when I lived in Vancouver. They were probably picturing something like the local ham radio swap meet they were dragged to when they were 5. They didn't get it. You won't get it either until you see it. Go see it. Are you aware of the system of precise dieting? This trend, which originated right here in China, has people across the globe measuring down to the milligram what they put in their bodies, based on the ancient principles of yin and yang. Actually, my fiancée Zhao Mei and I have been trying it this past month or so ourselves. It really boosts our stamina. I believe a portable food scale aimed at the precise dieting community would do quite well. Simple, we can include a tear function to zero the display when the power button is pressed. Call stamina. Gosh. I mean, it feels like this should be simple. I mean, this is essentially the scales we've got in our kitchen. Except that I think if you press the button, a short press of the button, it actually switches between grams and ounces, if it's on 0 at the moment. So that is without the tear function, I think. So that's a bad start. because it's moving the wrong... no. Have I got weight and button? I've got weight and button the wrong way around. Or rather, that one needs to be 1. Right. So that bit's all correct, but then it doesn't turn off properly. So let's just get it so it turns off properly. Oh dear. Yeah, okay, that's not going to work very well. Of course, now it just gets stuck in a tight loop where if you press the button, it bounces back and forth between the two things. So... It's meant to turn off the moment you press the button, so we can't move the slip down. So I think what I do there is I move the button press out of the way. Hang on, no, let me think about this. So I want to put the button testing, yes, first in the loop. And then we have an on there and an on loop there. And similarly here we have an off loop. But when we turn off, we jump in there. Have I forgotten something utterly trivial? Not obviously. Ah, the slip's in the wrong place, isn't it? On that one. Right, so everything apart from the tear function now works correctly. So that just needs that plus jump off to be probably we can be slightly sneaky here. Maybe we shouldn't be slightly sneaky though. Jump on B for on button, and then I'll improve this by one instruction later, maybe. If P1 is 0, then we need to mov P. If it's not 0, mov P1 ac. That's not quite going to work, is it? Dat. It is 0, jump off. Otherwise, jump on L. So that's not very helpful. Where does the tear function actually come in? It comes in there. And it does correctly save it and go back around the loop. And I think they're not sleep. Yes, that's kind of embarrassing. Why does it not end up sleeping then? Oh right, there isn't a slip in this branch anymore. Yes. That's kind of inconvenient. So, let's see, what do I want to do here then? How about if we implement, so the tear function we can implement by, so at the moment we do mov P1 straight to X3, and that won't work. We need to do some arithmetic. So we have to go for mov P1 ac sub dat mov ac X3. I have a horrible feeling we do. 3 instructions to get the comparison, to do the tear. Which means we need 3 spare instructions in something that's already quite crowded and doesn't work correctly. Yeah. So I'm inclined to feel that we can't fit quite enough program into this one processor. So that's about as simple as it can get. And the 2 loops do have to be separate, unless we can be very clever. So we have 3 things we might want to do. So can we do something cleverer here? We're still going to be very short of instructions. Because the general approach here is going to be something still can't remember which wire's which. So that at least works and would implement the tear function if the tear function were, if we had the right set of things to do with the button. And like we've got 2 instructions spare here, possibly more if we start getting clever. So then what we want to do is oh, except it's extra confusing because ugh. Because we don't actually want to reset when, to turn off when the input weight is 0. We want to turn off when the output is 0 and the button is pressed. Oh, maybe we test the button in 2 different places then. So something like if AC is 0 and I think I've got all my slips in the wrong place again. The awkward thing here is it needs to start displaying things immediately, but only test that after the first sleep. Right, so that's getting quite surprisingly respectable in that now it doesn't turn itself off when you press the button at the wrong time, and indeed Yes. But the tear function doesn't work, and we've only got one instruction left to implement it, finish implementing it in, which might be fine. So let's see, what do we want here? What we want is if P0 is greater than 50 and the accumulator is non-zero. So and we under some conditions we want to just do mov p1 dat. That is the only, we need to add one mov p1 dat instruction, which is brilliant, except we only have one instruction left to add it in. And we want it to be done in the circumstances where the button is pressed and the... Oh, can we do this? If we do TCP P00, then that gives us either plus or null. No condition. We will never get minus. Then teak AC0. After that, we'll have null, no condition if the button was unpressed, plus if AC equals 0, and minus if AC is non-zero. So we can do that. Damn it. Right, what have I got wrong? I've forgotten which way around my registers go again. Mov P1 dat. Can turn off that breakpoint soon. There we go. Finally a use for the ternary condition flags. And now I'm slightly scared by the people who do it in fewer lines of code than that. But definitely the yes, the landing on 5 yuan for one MC6000 is quite nice. Turn off the break. There we go. It is nice when the condition codes finally cooperate with me. Right, I feel that with that triumph, we'll read our email and then snooze. Yes, we guessed that that was what you meant by Zhao Mei. Also bloody silly alphabet. This truly is the essence of precise dieting in electronic form. Another great example of the confluence of ancient wisdom and modern technology. I'm excited not only to introduce this product to the world, but also for Xiaomei and I to use it ourselves. Surely you mean and me, I think. Oops, sorry, I forget not everyone here can read characters. Xiaomei is my girlfriend, Xiaomei. Anyone heard of the PGA 33X6? A pushy stall vendor nearly stuffed these in my pockets as I was walking through Huaqiang Bay last night. No idea what he was saying. Have some NAF undocumented chips, I suppose. Well, I guess we have a bunch of them, if anyone can figure out how to make use of it. Well, I read the spec for that, and I think I know what it is. Yes. Oops, hang on. I didn't mean that. Yes. The production cost histogram is essentially those people who manage to cram it all into one processor, and those people who don't. And those that don't immediately need at least 2 3-yuan processors, and probably a 3-yuan and a 5-yuan, which gets you up to 8, which I think is at that next bar. So yes, the datasheet for the PGA 33X6 makes it clear that it's a programmable logic device of some sort. We get, rather amusingly, the datasheet you get in the Chinese edition has basically the same text, because you get the text which is all in Chinese. But yes, it looks quite like that might be quite fun. You really are going after all the dubious possible markets, aren't you, Lily? We've partnered with a major financial services company to create a cryptocurrency deposit terminal for people concerned about turbulence in the financial system. The terminal reads an account number from a cheap magnetic stripe card, accepts a cash deposit, and sends the information to the bank over the internet. Because nearly all the money is flowing in a single direction, we just have to have it handle deposits. Right. Well, that's entertainingly complicated. Well, that should be fun, but not for today. Oh yes, actually what I was going to check was, do we get the PGA 33X6 available? Yes. So this is the component we've just received, with lots and lots of little things you can turn on and off. So that'll be fun. Do we get that back in any of the earlier projects? If we then go back to our, say, our precision scale. Right, that's now become available. So yes, we do actually get all of the earlier, parts to allow us to redesign every previous thing, which almost certainly allows you to simplify some of the earlier things. Right, well, I should actually, let's have a look at the spec for some of the others as well, in particular the control router, because I have no idea what this will look like. Smart grid control router. Meter in and meter out are X-bus inputs that connect this node to a building's smart grid power meter. Lower in and lower out are X-bus inputs and outputs that connect this to a node with a lower ID number. Higher in and higher out are X-bus inputs and outputs that connect this to a node with a higher ID number. The first value in a data packet is the ID number of the destination and indicates how the packet should be handled. If the ID is less than the meter ID, retransmit to a lower node. If it's equal to the meter ID, retransmit to the meter. If it's greater than the meter ID, retransmit to a higher node. The local ID is stored in a secure identity chip. The second value in the data packet is the length of the rest of the data packet. Right. Well, that's going to be a fun one to design, I think. Anyway, we can explore those at a later date. Dizzyet says no collisions. I think no time passing. But yes, it appears that you only ever receive signals from one source at a time, which is convenient. I mean, otherwise, you just lose packets anyway. You weren't expecting your network to be lossless, were you? So yes, the entertaining thing there is that the packets, I mean, they're all reasonably short, but they're of essentially arbitrary length, so we almost certainly have to squirrel the packet away in RAM somewhere and then read it out again later. Oh, we haven't actually used RAM for anything, so that might be quite fun. Plus, gods, how do we fit it all in? Because we're going to need, at the very least, some RAM and a CPU. And a lot of wiring. Like 6 X-bus? 6? I suppose we have the advantage that, like, yeah, what? That we wonder if we can connect together the three inputs essentially all do the same thing. So possibly we can just connect them together. We'll see. I think that will be the fun one for next time anyway. Right. So that will be all for tonight. Thank you for joining me and repeatedly explaining things until I got them right. Tonight we have constructed a haunted doll machine, which makes weird noises at random times. We have constructed, let's let this finish, the aquaponics maintenance robot, which moves a robot around and feeds and cleans the aquaponics cells. We have built a remote kill switch which turns on and off heavy equipment. And has a breakpoint. And we have built a pocket I Ching oracle, which reads microscopic yarrow stalks. And finally, a precision food scale, which takes advantage of the ternary condition flags to squeeze everything into a single processor with an on-off tear button. And we will be back on Friday, I think, to build probably the control router. So good night.